Welcome back to Question with Answer. In Part 3 of our SQL Interview Series, we bring you 10 more important and frequently asked SQL questions. Whether you're prepping for a technical round or brushing up your skills, these questions are designed to give you practical insights with concise explanations. Let's dive in and take your SQL knowledge to the next level. Question 1. What is the difference between delete, truncate, and drop in SQL? Answer. Delete is a DML command used to remove specific rows from a table based on a condition. You can roll back a delete operation if it's within a transaction. Truncate, on the other hand, is a DDL command that removes all rows from a table instantly, and it cannot be rolled back. It's faster than delete but less flexible since it doesn't allow filtering. Drop is also a DDL command, and it completely removes the table from the database along with its structure and data. Use delete when you want granular control, truncate for a quick cleanup, and drop when you no longer need the table. Understanding these commands helps avoid accidental data loss in real-world database operations. Question 2. What is a subquery and how is it different from a join? Answer. A subquery is a query nested within another query. It's typically used to retrieve values that will be used in the outer queries where, having, or select clause. For example, you might select employees whose salaries are above the average by using a subquery to calculate that average. A join, on the other hand, combines columns from two or more tables based on a related column. While both subqueries and joins fetch data from multiple tables, joins are usually more efficient and readable when handling large datasets. Subqueries are useful for filtering or when you need to use aggregate functions. Question 3. What is normalization? Why is it important? Answer. Normalization is the process of structuring a database to reduce redundancy and improve data integrity. It involves dividing large tables into smaller, related tables and establishing relationships using keys. The process follows a series of normal forms, 1NF, 2NF, 3NF, and so on, each eliminating a specific kind of data duplication or dependency. For example, storing employee department details in a separate table avoids repeating that information for every employee. Normalization helps ensure that updates, deletions, and insertions occur without introducing inconsistencies. However, in some cases, overnormalization may impact performance, so it's important to find the right balance. Question 4. What is the difference between a clustered and non-clustered index in SQL? Answer. A clustered index determines the physical order of data in a table and there can be only one clustered index per table. When you create a primary key, a clustered index is often created by default. Since it defines the data's storage, retrieving records using a clustered index is very fast. A non-clustered index, however, creates a separate structure that references the actual data rows using pointers. You can create multiple non-clustered indexes per table. While non-clustered indexes are slower than clustered ones, they're useful for optimizing queries on columns not used in the primary key. Choosing the right index type based on query patterns can drastically improve performance, especially for large datasets. Question 5. What is a primary key versus a foreign key? Answer. A primary key is a column or group of columns that uniquely identifies each row in a table. It cannot contain null values and must be unique. It ensures that no two rows have the same identity. A foreign key is a field, or collection of fields, in one table that refers to the primary key in another table. It creates a relationship between the two tables and enforces referential integrity. For example, department_ID in the employees table can be a foreign key referencing the department's table. This ensures that every employee belongs to a valid department. Question 6. What are indexes in SQL and why are they important? Answer. Indexes are special lookup tables that improve the speed of data retrieval operations on a database table. They work like the index of a book, helping the database locate information faster without scanning every row. When a query involves where clauses, joins, or order by, indexes can drastically improve performance. However, indexes come at a cost. They slow down insert, update, and delete operations because the index must also be updated. Over-indexing can lead to performance issues, so it's crucial to create indexes on columns frequently used in search and filtering operations. Question 7. What is a unique constraint in SQL? Answer. A unique constraint ensures that all values in a column or a group of columns are distinct across the table. Unlike the primary key, a table can have multiple unique constraints. It's useful when a field must contain unique values but doesn't necessarily qualify as a primary key. For instance, email addresses in a user table. Unique constraints help maintain data integrity and prevent duplicate entries that could otherwise lead to logical errors or faulty reports. When designing a database schema, applying unique constraints where appropriate strengthens the data model's reliability. Question 8. What is a case statement in SQL? Answer. The case statement is SQL's way of applying conditional logic in a query. It functions like an if-else block in programming. You can use it in select, where, order by, or even in aggregations to dynamically return different results based on specific conditions. For instance, you might use case to categorize salaries as low, medium, or high depending on value ranges. It's particularly useful when you need to create derived columns or apply conditional formatting within your results set without writing multiple queries or temp tables. Question 9. What is the difference between where and having clauses in SQL? Answer. The where clause filters rows before any grouping is done. It operates on raw data. Having, on the other hand, filters groups after aggregation and is used in conjunction with group by. For example, if you're finding departments with an average salary over $70,000, you'd use where to filter individual salaries and having to filter the group department results. Knowing when to use where versus having is critical for writing correct analytical queries that involve grouped data or summarized results. Question 10. What are window functions in SQL? Answer. Window functions allow you to perform calculations across a set of rows related to the current row without collapsing the results. Unlike aggregate functions, they retain all individual rows in the output. Examples include rank, row_number, lag, lead, and sum, over. These are especially useful for creating running totals, ranking items within partitions, like top 3 earners per department, or comparing values across rows. Window functions add powerful analytical capabilities to SQL and are widely used in business intelligence and reporting tasks. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.